Hi, welcome back to my channel. I appreciate you coming here. As always, if you like this video, please like and subscribe. If you have any comments or questions, please put them in the comment section, and I will try to respond as fast as I can. Today's video, we're going to talk about racking and what makes up racking and the components, and we're just looking at a few pictures of racking systems and the different types of racking systems that are available. Understanding what's available and out there might help you as you continue the journey toward getting solar and help you make those decisions. In this video, we're going to talk about racking systems. We're also going to talk about the types of racking systems that are out there that are generally used in most residential installations. And we're also going to kind of go into the different components that make up racking systems. I'm going to use EcoFasten pictures, but understand that most racking systems use pretty much the same type of parts to secure solar panels and inverters to a customer's roof. All right, first things first, what is racking? What do we mean by when we talk about racking? Well, racking and railing are all part of the hardware that is used to mount panels and inverters and wiring and other components to the roof, whether it's residential, commercial, all of them use some form of a racking system. Now, there are three basic racking systems that are used in most cases. When I'm referring to this as racking system, I'm talking about putting panels on a roof. There are variations of these systems that are used to mount panels on the ground, what we call a ground mount system. But for this presentation, I'm just going to talk about the racking used for installing solar panels on a residential roof. There are three basic types of racking systems. There's a rail system, there's a rail-less system, and there's a ballast system. These are the three basic systems that are used in the majority of all residential and even commercial installations. Now, these mounting systems have a variety of different mounts or brackets that can be used depending on the type of shingle and roof structure. Most roofs in the United States are going to have comp shingles. You're also going to have some that have metal roofs. Some are going to have tile. You might have some that have shake, slate, even different types of what they call TPO or membrane roofs. Pretty much a generic racking system. So a racking system that's made by EcoFasten or Iron Ridge or whoever is going to have the same basic components, and they will have different mounts depending on the composition of the roof, whether it's a shingle roof or a metal roof or a flat roof or whatever. When it comes to the rail or rail-less systems, those are generally used on roofs that have a pitch. Ballast systems are generally used on roofs that are flat or on warehouses, that have the flat roof and have a membrane roof. So these are the basic components of a rail system. And when I talk about a rail system, it means that there are rails that are used and mounted between brackets, and the panels and the inverters are generally affixed or attached to the rail. They come in lengths generally between 8 and 10 feet. They're an extruded aluminum, and they generally come in two different colors, usually silver or black. And in most cases, black is actually more expensive than silver, so majority of installations are actually done with silver railing and silver mounts and brackets. You have clamps. You have mid clamps and end clamps. These basically are what attach the panels to the railing system. They're adjustable, and they can be tightened or loosened as needed. You usually have some type of a wire management clip, a clip that hooks to either the rail or the panel, and it's used to hold in place the wires to keep them from dangling onto the roof. Honestly, most installers use some type of a zip tie. They're more reliable and generally are easier to use. Most rail systems come with some type of a splice. It's basically a small piece of rail that fits in between two rails and it's used to make a longer connection, a longer section of rail. There's really no limit to how many splices you can use in a solar system. It really depends on the size of the roof and how many rails are how many sections of rails are needed in order to mount the panels to a roof. Most systems have some type of an end cap. It's just a cap that goes over the railing at the end. It makes it look prettier, and in some cases they actually are colored black so that it looks a little bit better against the shingles than, let's say, just aluminum metal sticking out. L-feet. All systems have some type of an L-feet. L-feet are basically the mounting bracket that is affixed to the roof. So there's actually a bolt or a screw, a large screw or a bolt that is screwed into the roof, and this is what secures the entire system to the roof. Flashing is just that. It's a piece of metal. They can be anywhere from a 3-inch disc to 6 by 8 inches aluminum metal. They go under the shingles and are sealed with some type of a tar that will help prevent leaks in the future. Most systems also have a module jumper. All this is an electrical ground that attaches all the panels together and then is wired to a grounding wire, and it grounds the whole system. And then you usually have some type of an inverter clamp or a mount. This is a bracket or a clamp that is attached to the inverters and then is mounted to the rails. And I'm going to show you some pictures here in just a second what those look like. On a railless system, the terminology is a little bit different, but the functionality is pretty much the same. In a railless system, you have a mount. The mount connects 2 panels to a slide. A coupling connects 2 panels together, and then you have a skirt. So instead of having 8 or 10-foot sections of rail that are aligned throughout the system, you actually have a skirt that is attached to the leading edge of the panels. So only the first row of panels would have a skirt. The skirt provides some structural support, but really it's there to make sure the entire system is level, that all the panels are level and straight. You have a slide. The slide is basically about an 8-inch section of metal. It looks similar to a rail, but it's very small, and it basically is replacing the L-feet on a rail system. So you would have the mount that would connect to the slide, and the slide would be screwed into the roof. Flashing is just a flat piece of metal that's used to seal any penetrations in the roof and to help prevent leaks. An inverter mount is basically a bracket that connects the inverters to the panels. The problem with the inverters on a railless system is that you can only use a single inverter. You can't use a double or a quad. They're just too heavy. They would actually break the edge of a solar panel. So on a railless system, one of the downfalls is you can only use a single inverter system. So basically 1 inverter per panel. You couldn't use let's say like an AP Systems quad, where you would have 4 panels connected to 1 inverter. The inverter is just too heavy; it would damage the panels. So these are the components of a railless system, and we're going to kind of show you each one in the next slide. So in this slide, you can see the different components. You can see a picture of the rail with an end cap. You have a mid clamp, which is basically what it says. It attaches panels to the railing system in the middle areas of the system. The end clamp is what it says. It attaches the panels to the rail at the ends of the system. The end cap just goes on. In this case, for EcoFasten, it goes on and it makes the whole system look cleaner. Other rail systems have end caps, or in some cases they don't have end caps. They just have the rail stick out. You have an L-foot that supports the rail and is screwed into the roof. Your rail splice, as you can see there, just connects 2 pieces of rail together. Your wire management clip hooks over the rail and is supposed to be a system that allows wires to kind of be secured and not dangle onto the roof. Your flashing, there are different sizes of flashing. You can see it's got kind of a little nipple that sits up. That's what the L-foot is screwed into, and then that's directly screwed down into the roof to support the rail system. Next you have an inverter mount, and that hooks into an inverter and then clamps over the rail and is tight and allows inverters to be mounted. And then you have a module jumper. A module jumper is jumping electrical ground. It makes sure that all the panels are connected together and ground. So as we talked about, an railless system has a few less components. You have a mount. We talked about that. We have the coupling. And then you can see here the skirt and kind of how that aligns with the top of the panel. It gives it a very sleek look. And I've got some pictures that'll show a better look later in the presentation. But really the skirt is just designed to level and make sure that those panels are all even and level and look really good. The inverter clamp, again, this is designed to mount an inverter directly to the panel. And as I said, this is a pretty weak system, and even in this EcoFasten system, but in other rail-less systems, it just doesn't have the strength to support anything other than a single inverter. There's your slide. That slide sits on top of the flashing and is drilled into the roof to basically provide the support and the structural integrity so that system is mounted correctly to the trusses. It also provides an area to seal with a type of a tar that allows the system to prevent leaks. So as you can see here, here's a couple of pictures of a rail system. You can see here, you can kind of see the rail stick out of the end. Most rail systems have some type of a cap, or in a lot of cases they just don't put them on, or they don't have a cap, they just let the rail stick out. You can see here where you've got the three rows of rails, so there's going to be 2 rows of panels here. And as this lower picture, you can kind of see underneath the panels, since there's no skirt, you can just kind of see underneath the panels. And you can see here you can see on the left hand side of the picture, you can see some of the components sticking out. That's kind of one of the problems with the rail system. It's just the way it looks. As you can see here with the rail-less system, you have this skirt, kind of gives it a sleek look. There's 2 pictures here of panels with the skirt on them. The skirt really does provide some structural integrity, but really it's just designed to, number one, look sleek, but also to make sure that all these panels are level and everything's even and looks good. And you can see here there's a lot less components. You don't have that rail running down the middle. You just have the flashing with the slide and then the mount. So you can see it's a lot less components, and in my opinion, it actually looks better. So one component of mounting systems that is changing and gaining popularity is what they call a direct-to-deck system. So in a rail or railless system, the feet or the slide have to be screwed into a truss. That's the only way it can support the weight of the panels and provide the structural integrity to withstand winds, bad weather, things like that. Direct-to-deck systems actually have 9 screws that are screwed directly into the roof sheeting and are supposed to provide the structural support just as if it was going into a truss. I'm not sure how this is working right now as far as engineering and stuff like that. And it's possible that this can't be used in areas that have, let's say, high winds like tornadoes, like Florida, Texas, several of the southern states where they have those really high wind threats. This is something to watch in the future, but it is something that's going to gain in popularity because it's easier to mount than a rail or railless system as far as a normal L feet, because you don't have to locate a truss. You just have to screw it into the deck. And then you can go about installing the rest of the system. So this is going to save some time on installation. So this is something that you will start seeing more in the future. Well, thanks for watching this video. Hope you enjoyed it, and hopefully we've answered some of your questions about solar and giving you some insight into one of the components of solar systems.